Evolution of language, Babel or Babel. Languages all have their roots in the same part of the world, but they are not as similar to each other as was once thought. Where do languages come from? That is a question as old as human beings' ability to pose it, but it has two sorts of answer. The first is evolutionary, when and where human banter was first heard. The second is ontological, how an individual human acquires the power of speech and understanding. This week, by a neat coincidence, has seen the publication of papers addressing both of these conundrums. Question Atkinson of the University of Auckland in New Zealand has been looking at the evolutionary issues, trying to locate the birthplace of the first language. Michael Dunn of the Max Planck Institute of Psycholinguistics in the Netherlands has been examining ontology. Fittingly, they have published their results in the two greatest rivals of scientific journalism. Dr. Atkinson's paper appears in Science, Dr. Dunn's in Nature. Traveller's Tales. The obvious place to look for the evolutionary origin of language is the cradle of humanity, Africa. And to cut a long story short, it is to Africa that Dr. Atkinson does trace things. In doing so, he knocks on the head of any lingering suggestion that language originated more than once. One of the lines of evidence which show humanity's African origins is that the farther you get from the continent, the less diverse, genetically speaking, people are. Being descended from small groups of relatively recent migrants, they are more inbred than their African forebears. Dr. Atkinson wondered whether the same might be true of languages. To find out, he looked not at genes but at phonemes. These are the smallest sound which differentiate meanings, like the th in thin replaced with f or s, and the result in it is a different word. It has been known for a while that the less widely spoken a language is, the fewer the phonemes it has. So, as groups of people ventured even farther from their African homeland, their phonemic rep- repertoires should have dwindled, just as their genetic ones did. To check whether this is the case, Dr. Atkinson took 504 languages and plotted the number of phonemes in each against the distance between the place where the language is spoken and 2,500 putative points of origin scattered across the world. The relationship that emerges suggests the actual point of origin is in Central or Southern Africa, and that all modern languages do indeed have a common root. That fits nicely with the idea that being able to speak and be spoken to is a specific adaptation, a virtual organ, if you like, that is humanity's killer's app in the struggle for biological dominance. Once it arose, Homo sapiens really could go forth and multiply and fill the earth. The details of this virtual organ are the subject of Dr. Dunn's paper, confusingly though. For this neat story of human imperialism, his result challenges the leading hypothesis about the nature of the language organ itself, grammar or just rhetoric. The originator of that hypothesis is Noam Chomsky, a linguist at the Massachusetts Institute of Technology. Dr. Chomsky argued that the human brain comes equipped with a hardwired universal grammar, a language instinct, in the elegant phrase of his one-time colleague Steven Pinker. This would explain why children learn to speak almost effortlessly. The problem with the idea of a language instinct is that languages differ not just in their vocabularies, which are learned, but in the grammatical rules, which are the sort of things that might be expected to be instinctive. Dr. Chomsky's response is that this is diversity, like the diversity of vocabulary, is superficial. In his opinion, grammar is a collection of modules, each containing assorted features. Switching on a module activates all these features at a stroke. You cannot pick and choose within a module. For instance, languages in which verbs precede objects will always have relative clauses after nouns. A language cannot have one but the other. A lot of similar examples were collected by Joseph Greenberg, a linguist based at Stanford who died in 2001. And though Greenberg himself attributed his finding to general constraints on human thought rather than to language-specific switches in the brain, his findings also agree with the Chomskyan view of the world. Truly testing that view, though, is hard. The human brain cannot easily handle the connections that need to be made to do so. Dr. Dunn therefore offered the task to a computer, and what he found surprised him. Place your bets. To find out which linguistic features travel together and might thus be parts of Chomskyan modules, means drawing up a reliable linguistic family tree. That is tricky. Unlike biologists, linguists do not have fossils to guide them through the past. Also, languages can crossbreed in a way that species do not. English, for example, is famously a model of German, Norse, and medieval French. As a result, linguists often disagree about the tongues belong to a particular family. To leap this hurdle, Dr. Dunn began by collecting basic vocabulary terms, words for body parts, kinship, simple verbs, and the like, for four language families that all linguists agree are real. These are Indo-European, Bantu, Austronesian, and Uto-Aztecan. These four groups account for more than a third of the 7,000 or so tongues spoken around the world today. For each family, Dr. Dunn and his team identified sets of cognates. These are etymological related words that pop up in different languages. One set, for example, contains the word like night, nacht, and noit. Another includes milk and milch, but not light. The result is a multi-dimensional Venn diagram that records the overlap between languages, which is fine for the present, but not much use for the past, to substitute for fossils, and thus reconnect the ancient branches of the tree as well as the modern day leaves. Dr. Dunn used mathematically informed guesswork. The maths in question is called the Markov chain Monte Carlo method. As its name suggests, this spins the software equivalent of a roulette wheel to generate a random tree, then examines how snugly the branches of that tree fit the modern foliage. It then spins the wheel again to tweak the first tree ever so slightly at random. If the new tree is a better fit for the leaves, it is taken as a starting point for the next spin. If not, the process takes a step back to the previous best fit. it. The wheel whirls millions of times until such random tweaking has so discernible effect on the outcome. When Dr. Dunn feed the languages he has chosen into the MCMC casino, the result was several hundred equally probable family trees. Next, he threw 8 grammatical features, all related to word order, into the mix and ran the game again. The results were unexpected. Not one correlation persisted across all language families, and only 2 were found in more than one family. It looks, then, as if the correlations between grammatical features noticed by previous researchers are actually fossilized coincidences passed down the generation as part of linguistic culture, nurture, in other words, rather than nature. If Dr. Dunn is correct, that leaves Dr. Chomsky's ideas in tatters and raises questions about the very existence of a language organ. You may be sure, though, that the Chomskyan heavy artillery will be making its first ranging shots in reply, even as you read this article. Watch this space for further developments.